Stopping distances. Learning objectives. Know how to calculate total stopping distance. Know what thinking distance is and factors that affect it. Know what braking distance is and the factors that affect it. Know typical human reaction times and how they are determined. The total stopping distance in metres is calculated by adding the thinking distance in metres to the braking distance in metres. The thinking distance is the distance you travel whilst thinking about pressing the brakes. You can also say it's the distance you travel during your reaction time. The braking distance is the distance you travel once the brakes have been pressed. Let me help you understand by showing an example. Imagine a car driving along a road. All of a sudden, a big deer steps out into the middle of the road. The deer is the stimulus. It triggers your brain to send a signal to your foot to press the brakes. Now, it takes about 1/4 of a second for the signal to travel from your brain to your foot. And during that 1/4 of a second, your car is still travelling forward. The distance you travel during this reaction time is called the thinking distance, because it's the distance you've travelled while you were thinking about pressing the brakes. Now, just because you press the brakes doesn't mean that the car is immediately going to come to a stop. The car has to physically come to a stop. The distance the car travels under the braking force is called the braking distance. To work out the total stopping distance, you simply add the thinking distance to the braking distance. Let me pop some values in so you can see a typical question. Just say the car is travelling at 40 miles per hour. The typical thinking distance will be 12 metres and the typical braking distance will be 24 metres. So the total stopping distance will be 36 metres. Here's a graphic taken from the Highway Code, which is a book that contains everything you need to know about driving on roads in the UK to pass your driving theory test. And by the way, if you're wanting to pass your driving theory test, you need to memorise these values. The graphic shows the typical values of thinking distance and braking distance needed to stop your car in an emergency when travelling at certain speeds. You don't need to memorise all these values for your GCSE physics exam, but you do need to know how to handle this data by adding the thinking distance and braking distances together to work out the total stopping distance. Now that we know what the thinking distance and braking distances are, we need to know about the factors that increase these distances. Factors that increase the thinking distance are any factor that slows down your reaction time. So, if you've been drinking alcohol or taking drugs, or if you're distracted by your mobile phone or distracted by other people in the car, or if you're tired because you haven't slept properly the night before, these are all factors that will increase your thinking distance by increasing your reaction time. One factor that will increase your thinking distance but won't increase your reaction time is travelling at a faster speed. Your reaction time will still be about 1/4 of a second, but you will travel further in that 1/4 of a second if you're travelling faster. Factors that increase the braking distance are usually any factors that make the amount of friction between the car tyres and the road surface less. So if your car's got worn out brakes or worn out tyres, or you're driving in poor weather such as rain or ice, which could make your car skid, or if there's loose gravel or mud on the road surface that could make you skid, having a heavier car will mean the car has more momentum and more energy, so it'll be difficult to stop. Not only will faster speed increase the thinking distance, but it will also increase the braking distance as well. So that's a good factor to remember for your exams. How to measure a human being's reaction time. The typical reaction time of a human being is about 1/4 of a second, which is very fast. So we usually use computers to measure it for us. A reaction time is the time it takes to respond to a stimulus. For example, if we get a computer to turn on a light, the light is the stimulus. The human has to quickly press a button to turn the light off. Pressing the button is the response. The time taken between the light turning on and the human pressing the button to turn the light off is the reaction time. Well, I hope that was useful. Subscribe to the channel to see more videos like this. Work hard, be nice, stay safe, and bye for now.